So one fact is always to do the measurement against the standard. Here we have a typical measurement against the standard. You can see the limit values. Attention, these are not the limit values of Australia, when I remember well. This is from IEEE from the USA. But in Australia and IGNIP and here in Germany, we have round about the same curve. So here between 30 megahertz to 300 megahertz, we have very low limit values in milliwatts per centimeter square indicated. We have here 10 times the values or 3 times in voltage. We have here above 2 gigahertz the limit values and so on. And again, to lower frequency is rising again. So imagine you now have 3 transmitters, one at 1 megahertz, another one at 100 megahertz, and the third one at 9 megahertz. Indicated here in the table. I hope you can see the pointer. And the power density of each signal is indicated here. So for 1 megahertz, the power density is 4 milliwatts. For 100 megahertz, the power density is 0.5 milliwatts. And for 900 megahertz, again, it's 0.5 milliwatts. So in total, you will get a value of 5 milliwatts per centimeter square. So the question is now, does it exceed the limit value or not? So remember, the lowest limit value is 1 milliwatts per centimeter square. The highest one is 100 milliwatts per centimeter square. You can say, I'm exceeding the limit value for sure if I'm above 100 milliwatts per centimeter square. Then it doesn't matter at which frequency it is, I will be over the limit value. If I measure below 1 milliwatts per centimeter square, I can say I will never exceed the limit curve because I'm always even below the lowest limit value. So 5 milliwatts puts us a little bit into trouble. I don't know, therefore I need the information about the frequency. So this is something which will be taken into account with so-called shape probes or shape measurements. So then you take into account, for example, the 4 milliwatts per centimeter square. The limit value here is 100 milliwatts per centimeter square. This means this is 4%. This here is 50%, and this here, the 900 megahertz is 17%. So in total, we have 71% of standard. Means it's telling us we are below limit value. We are on the safe side. So 5 milliwatts, I don't know. 71% is a clear indication. No trouble. So if I now change the distribution of the signal a little bit like this, I again have here reduced power on 1 megahertz, therefore higher power at 100 megahertz and 900 megahertz. For the linear adding of the signal, again I have my 5 milliwatts per centimeter square. Again, I don't know. If I calculate it directly in percent of standard, I see here 2%, here 100%, here 67%. So in total 169% means I'm in trouble. So the measurement in percent of standard is always makes life much easier, okay? Milliwatts per centimeter square sounds very sophisticated to engineers, but finally the percentage helps more. I always compare it with my favorite mineral water. So if you look to a bottle of mineral water here in Germany, on my favorite one, I have a bottle here with me, it tells me this water contains 354 milligrams per liter hydrogen carbonate. This seems to be a high sophisticated measurement result, but at the end of the story it doesn't tell me anything because I'm not a food scientist. What I want to know is, can I use it for preparing baby food? And they tell me 354 milligrams per liter hydrogen carbonate. This is not the correct answer to me. So I would love to have an indication like this. Yes, you can use it for baby food. So there is an indication, language for scientists, 354 milligrams, and there is a language for general public. You can use it for baby food. So somebody has to translate it from one into the other one. So best is if you can speak both languages, if the instrument can read out in both languages. I can show you the same again. For example, here in low frequency, we have taken a low frequency tester and it's telling me I have 45 microtesla at 1 kilohertz. Is it dangerous or not? I'm not sure. I can show you the same result also in spectrum analysis. Doesn't help much. But if you switch the instrument into percent of standard, it's telling me 150%. This means I'm in trouble and I have to react. If I want to find out why do I have 150%, then I need an engineer who can make this evaluation. There are those modes showing, for example, spectrum analysis can have a lot, but therefore you also have to have some experience. But an instrument showing directly the result in percent of standard, you can even give to your neighbor and he will understand that in this case he's in trouble.